Okay, we're back. And today I've got some fun stuff to show us. A few different things I've been working on. So small steps every day. And so even though I didn't do a podcast yesterday, I was working on some stuff. And I'm pretty excited to show all of you some things that I figured out. And for today, I'm thinking what we might do is have these be, this channel is all about iterative refinement. It's this whole Archimedean spiral thing that I love to kind of live by, which is, I don't really know what I'm doing, but I have a direction that I'm heading in, and I think that direction is generally right-ish, but the exact details of how this all pans out, those things are maybe a little bit blurry. And this is sort of how my life has been for the last 30 years. And in fact, I think there may be a virtue about this notion of try to be directionally correct, not like specifically correct. And this allows you to move. I know that this is somewhere, but I might not have included it here. Let's see here. Oh, see, I'm organizing my thoughts before speaking. Or maybe I'm a little late for that. Whatever the case is, I think that it's important to sort of be directionally correct. But the specifics you may not always know about. And what I find is that they become clearer as you get further along in the process of things, if that makes sense. And so I will often not know the specifics on how I'm going to do something, but I know I'm going to do this thing. And then how I go about doing that will change as new data arrives, because I just don't know all the stuff that I might need to know. And this sort of follows this notion of one of the things that I do when I'm making decisions about things that I want to do. I'll ask questions like, why? Why am I doing this? Why does this matter? And once I get the right why answers, for example, I asked many, many questions about why I want to consistently teach at the university and do research with other faculty and students. And once I sort of deeply navigated the why questions, then I realized, oh yeah, I'm going to just commit to this. This is maybe going to be something in perpetuity for my life. And I did similar things with Merle, asking questions of why would I do this? Why would I leave a research lab that I had founded and was directing with an entire research team that I kind of had assembled myself? Why would I give all of that up to do this other thing, which is far more nebulous and uncertain? And then once I kind of answered those why questions, it became obvious that I need to do this. And then exactly what we're going to do at Merle and who's going to be involved, we'll figure those things out. And in some sense, I'm following this principle of not getting distracted by the little things. which is a cornerstone of what I want to discuss today. There's actually something really important to discuss about this, a fun story that I have. But similarly, when I was thinking about the Goju Tech Talk channel, which many of you may not realize, but I was contemplating doing this channel for several years before we actually started recording. And it initially started with the channel that existed before GTT, which we called MPT, Machine Programming and Technology. And the goal of machine programming and technology is very similar to GTT, is that it was meant to educate and share things about machine programming. However, it had a slightly different format, and it wasn't quite jiving with me as far as it was too, I think, formulaic. It was too by the numbers. It didn't feel dynamic enough. It felt too, I don't know, forced in some sense. And authenticity is really important in my mind. I think that there's, I don't know, I feel like today, I'm really going off on a tangent here. We haven't even talked about the virtues, but what the heck? Let's go down this rabbit hole. I feel like today I was actually talking with Urs about this yesterday. And we were noticing that people seem to be very polarized today in society at large, and not just in the United States, across the world. I interact with people all over the world. I have students that are international, professors, other founders, including our employees. Urs himself is from Switzerland. And yeah, so there's a lot of diversity. And what we're seeing is a lot of people seem to be pretty polarized today. And we were talking about how I think that that's not always a great thing. I think that we should maybe have a little bit less polarization and not go down this path so much of you either fully believe this thing and you're 100% in, or you don't believe it and you're 1,000% out. Like, there can be middle ground here. There can be spaces where you like this thing, but it has trade-offs and it has weaknesses. And so you can use it when it makes sense, but then there are other cases where maybe it doesn't make sense, and so you don't use it. And that's actually part of how we build our tech at Merly. And it's sort of the way that I try to teach, is that it tends to be the case that really important things tend to be nuanced. And with nuance comes complexity. Things are complicated. And this whole soundbite era that we live in today with TikTok, of trying to express something in 15 seconds, I think I'm not a huge fan. I think things often require, especially complex things, they often require more time, which is why we're focused more on the long form. And I understand, too, that lots of people, especially in today's era, may not be big fans of long form. And that's okay, too. Those people I think there's a plethora of things out there in the world where people can engage in the shorter form. You know, you have the YouTube Shorts, you've got Instagram, you've got TikTok. Everywhere you turn, it feels like there's the short form. And I feel like there's very few places that are actually more the long form. And I think that YouTube long form is a really good space for that. So with that said, it was sort of clear that this is the direction we want to go in, I think, for Goju Tech Talk. But then all the specific details about how it would work and what we would show and how we'd get this sort of authenticity, there were a number of things that kind of needed to be in place before we were, I think, ready to do this. Part of it is I needed to learn more to understand how to get all the tech organized, how exactly these episodes would happen, this type of thing, what we would talk about, what would be sort of on topic versus off topic. And I do have certain rules about things that we will or will not talk about. And so one of the things that I'm going to try really hard to not talk about are things that would be personal judgment on hot topics that maybe I'm not the best person to give feedback on, whether that be highly charged political things, highly charged religious things. It feels like people will often have strong opinions on these things, and I think that people can do what they want to do, and what someone's political affiliation or religious affiliation or things of that nature are, I don't know that that is something I would try to influence in any capacity. I think that people should make their own decisions about these types of things. And my general view is if you're not really hurting anyone else with the decisions that you're making, then what do I have to say about that? Probably very nothing, probably very little. And it probably makes sense for me not to say things, because this might again be getting distracted by the little things, not focusing on the things maybe that really matter. So there are these rules that we follow, and we're going to figure certain things out, but we have the infrastructure, I think, in place now for the foundation of GTT, and we're going to iteratively evolve, Archimedean spiral this out, and do all this adaptation. And along those lines, there's cool things that I'm figuring out. And there's also, I think, kind of cool stories that I want to share that, at least for me personally, I think are things I've learned that have helped me come up with many of these life virtues. And I think that goes back to where I was going, is now what we might do is have these life virtues, which are things that are like general approaches to things in life that we can apply generally, no matter, sort of what scenario you're in. And if you're a technologist, great. If you're not a technologist, great. These things can probably just help you regardless. I'm a technologist, so I can only speak maybe from my experience, but maybe you're a medical doctor, or maybe you're a teacher, or social worker, or police officer, fireman, librarian. And I think these general life virtues probably have application, or at least people have told me they feel they have application kind of in a domain-independent way, which is great. And that's part of the reason to zoom in on these. However, there's also tech virtues that I want to teach, I want to discuss, I want us to deliberate on. And that's also really important to me because while I think the life virtues are fantastic, I am a bit of a tech nerd, and I do sit around at night thinking about things like, if only the world knew that you should generally prefer equality over inequality, our mathematics would probably be so much simpler. And so I feel like I have an obligation to explain this, because I think that maybe once I explain it, it will kind of make sense. And then people might be writing code that's more aligned with this. And I suspect that many people, just like myself, were not taught this. But then once you have this sort of eureka moment of, oh, that's why, then we start to have these tech virtues that we can follow. I think I'm supposed to write like a couple different books on this, like books on software engineering, machine programming, programming languages, all this stuff. And I'm doing a really terrible job writing these things. So to anybody that's listening that you're waiting for these books to appear, I apologize. There might be one in progress, and I apologize if my co-author is watching this wondering, where's the book, Goju, versus more GTT episodes. But I'm a little oversubscribed. But I'll keep moving forward. Anyway, so this is the higher order bit. We're probably going to, this is where I'm starting to lean. We're going to do life virtues and tech virtues, and maybe hit these every episode, every other episode. We'll kind of pivot. So for this episode, mastering the basics, we're going to do more of that. Never stop growing. That one's really important. And I've got a couple that I've learned, which I'm super excited to share about. And then not getting distracted by little things. This is a story I want to tell. On top of that, I do want to give an example on how we should prefer equality over inequality when we can. And we should prefer that in our code, because it's likely going to make your code easier to reason about, both for yourself and for others. Okay. Then as a company highlight, I want to talk a little bit about Everything Money. These guys over here. We're going to maybe watch a short little episode from their shorts. Oh, looks like that thing just switched on me. That's cool. I'm learning new things all the time. Thought I closed that, but okay, there's Everything Money. All right. And then, yep, we're going to talk about that. We're going to talk about this. And then today's tech, this thing called Super Display. Okay. Cool. So now we can actually talk about some of these things. Let's start with Everything Money. So the background on Everything Money is we are starting to work with these folks, which is fantastic. And we are going to be using Mentor to help them with their code quality. They have bunch of code and a bunch of different repositories, and these folks, as I understand it, are world leaders in reasoning about things related to money, which is kind of fitting given the prior episode was don't focus solely on the material, and now we have a company we're working with called Everything Money. We can see the complexity of this. But as you probably recall, I didn't say you shouldn't think about money. That money is definitely something I think that should be on your purview, but maybe not number one. And so while it could be that this is purely their company, it could be that this is also what they believe. Whatever the case is, I think that they're doing some interesting stuff. And in fact, I was watching one of their shorts, and I thought it was actually kind of interesting. So I would like to watch one of these shorts. I think it's this one. Earnings season is here, and hopefully this works. By the way, I have like 15 different things running in tandem, so hopefully this works. But I've got like my tablet thing connected over here. got maybe the 3 or 4 monitors, the webcam, the mic. I'm also playing Raphael over here, and this is just kind of in the background with low volume. And so hopefully this continues to play while we do this. We're going to probably iterate, but let's give it a shot and see what happens. Here we go. I think maybe that's too quiet. We're going to pause this. We're going to turn this volume up higher. Then we're going to turn this volume up a little bit here. And we're going to try this again. Here we go.
Season is here, guys. Earnings are going to be a very, very pivotal moment for the stock market. Right here I have the SPY up. You need to pay attention to the 200-day moving average. This 200-day moving average is everything. You notice that here in early October, the stock market did drop. It kind of hovered around this 200-day moving average, and it pulled right back up. What would push the market down to this 200-day moving average? Well, it's two things. Number one, XLF. That's the banks. This is the big bank ETF. If the big bank ETF does fall, because banks lead markets, if the big bank ETF does fall, that's what is going to start moving this thing down. Also, your things like NVIDIA. You're going to have to pay attention to NVIDIA. See what that does. If that drops below the 100-day moving average, we're moving down. Apple, if that starts moving, falls below the 25-day moving average towards 200, we're moving down. Pay attention to the big banks. Pay attention to big tech this earnings season. Earnings season is here.
Cool. So some of what he said, I'll be honest, I don't understand, but I like it. Oh, did I like it already? Is that liked? Okay, now it's liked. Okay, now I'm subscribed. Cool. So yeah, check them out. I didn't follow everything that he said, but I will say that from a tech perspective, I do follow the big tech companies like NVIDIA and Apple and others, and I do think that there is an indication of where things are headed based on this. I have some more thoughts about this, which, as I suspect all of you probably know, are probably going to be pretty complicated. But I like what he's saying about this 25-day average and watching things. So it's not like immediately reactive. You're kind of watching a little bit for various trends. And this is similar to what I try to do with data, is I'll try to collect data and make sure I have enough substantiation on things before I start to move in a particular direction. And so it seems like, at least with this one short that we watched, they are using a similar kind of data-driven approach. And it looks like there's a bunch of things to check out. So I'll be watching and learning about what they're interested in as we work with them more. And we're super excited. And in fact, if you check the Merly website, you'll probably see, hopefully, some feedback from Everything Money on us and how hopefully we're adding value to their company. So cool. I'm excited about that. You know, the word's slowly getting out. Okay, so there we go. We spoke a little bit about Everything Money. And, oh yeah, just real quick shout out. I'll try to continue to change the song. And maybe I'll swap company and games. I'm not sure exactly what I'll do here. If people have ideas, let me know. This can be a rotating category. Maybe it's company. Maybe it's game. I'm not sure. But music is so important to me, and there's so many songs. I think that we got to do this every time. So song for today, Radiohead Creep. If you haven't heard it, definitely give it a listen. It's one of my all-time favorite songs. And in fact, my brother and my really good friends, they probably know how much I love this song because I mentioned, like, in a former life, I used to sing. And if you ever get me out in karaoke, which is pretty rare to do, but if you do it, Or we have a rock band night. Give me that microphone. I will throw down on Radiohead Creep. Actually, almost anything Radiohead, but this one in particular, I just love this song. I like how it's nuanced and it meanders. It has a certain honesty to it that I really like. How he's, I think, in some ways, being honest about how he needs a lot of work, and he's not nearly as good as the person he's interested in. But it's not gonna like sway his interest. Something to that effect. Just a good, level of authenticity is maybe what it is. I like it. Okay. So now let's go to this. Don't get distracted by little things. This is one of the main things I want to talk about, and this is going to be Goju story time. So if you have popcorn, you may want to pause this and heat up the popcorn and get your favorite soda or tea or whatever it is that you drink. Get ready, because we're going to take us a little bit down a journey here. And keep in mind, this is a completely true story, that none of the details of this are manufactured in any way. I'm probably going to leave some names out of the story, just because my intention is not to pick on people. I'm going to turn this back down a little bit. There we go. Maybe it's too quiet now. Okay. I want us to have a little Raphael playing in the background. One, because it motivates me, but two, it's kind of like free publicity for him. Then maybe you'll listen to his stuff too, so yeah. And it is just great, I think. Okay. So, not sweating the small stuff, or not getting distracted by the small things. Oh wow, that's coming in on the mic too much. Okay, I'm going to have to turn this down. Sorry guys. Clearly this is a learning episode. We'll just turn this down and we'll just turn this down here. Okay. So not getting distracted by the little things. Let's talk about let's talk about an event that happened. This is back in 2010, I think. 2010? Yeah. I'm finishing up my PhD at University of Colorado Boulder, and I think I finally kind of hit my stride in terms of I'm able to actually do a little research, and I've broken into what people might think is at least the space of a tier 1 research venues, which, by the way, was very hard for me. One of the hardest things I've ever done, at least to that point in my life, and I had to learn quite a bit in a number of different things that I had no idea would be my weaknesses to get these publications. And so at this point, I think maybe I had one solid tier 1 pub, and I had maybe 10 or so pubs that were like workshop papers or 1 or 2 page short papers at good venues like Podsy, which is something about it's principles of distributed computing, I think maybe. And I had like a full paper at CGO, code generation and optimization, and then a bunch of like a full paper at LCSD, library-centric software design, LDSC, yeah, and others, right? So that's cool, and mostly I'm just happy at this point that I appear to be getting done with my PhD. that I can kind of see the light at the end of the tunnel. And I think at this point I had successfully defended my dissertation. And it was at the dissertation defense where, after the defense, I was starting to get feedback from my committee. And the feedback was, if I recall correctly, that basically accepted with no revisions, which is, as I understand it, somewhat unusual. Unusual in a good way, at least for me, meaning that I probably don't have to do any more work, which I was super happy about. And I don't know that I fully understood how big of a deal this was at the time, but leading up to this, there were definitely moments where I was wondering, okay, am I just going to get eaten alive at my dissertation defense? And my advisors were tough on me. They were fair, but they were tough. And so I was expecting that I'm kind of going to be eaten alive, but I'll get through it. So I was coming into the dissertation defense like, okay, you're going to be thrown to the wolves, but just survive and you should be okay. And what appeared to happen actually in the defense was it was really good. It was much better than I was expecting, I think, maybe even better than my advisors were expecting. And there were some questions. And I think at one point, Morris, who we've discussed in prior episodes, he chimed in and he asked one question. I think I totally bombed Morris's question. And I think he said, basically it's the exact opposite of what you just said, which was his sort of nice way of saying, yeah, you totally failed that question. And you're completely wrong. and in hindsight, I think I was completely wrong. So that question aside, I think that one, I struggled with quite a bit. And I do think, again, that Morris was right. I think he was asking me a question about contention management and how will this work. This was like, just to give you context, this was one of the first times that people were asking me questions like, how would you integrate this software system into a hardware system? And how would you do these sort of like hybrid transactional memory systems? And the reason why this question was like a little foreign to me is I'm just a lowly grad student. What do I know? And so I just am trying to write a system that works. And then suddenly people were like, well, not only does this work, you could go further with this. And at this point, I'm sort of like, wait, what? And there were these questions about hardware, and Intel was asking, and they were asking, and I was like, I don't know. I don't know that much about hardware. And then they were like, you're getting a doctorate in computer engineering. How do you not know about hardware? And I'm like, no, I know about hardware, but like, I'm not like a micro architect for CPUs or GPUs. Like, I understand the basics. I could teach computer organization or computer architecture. I understand caches and registers and functional units and all that, but like how to design a transactional memory system that's both software and hardware, like, I don't know. There's got to be other people that are way smarter than me. So I was getting these questions, and part of it was making me pretty excited because it seemed to be that people were implying there was like this subtext of, oh, people think this could actually work. And so we could do more than just a software. This could be integrated into hardware too. And again, I was just trying to finish my PhD. I didn't have any kind of grand delusions of this is going to change the world. Those thoughts maybe came and went after my first year in the PhD program when I realized, like, sort of the world thought my research kind of sucked. And that's not me being negative about this. This is me, like, reading the rejections over and over about, like, your stuff kind of sucks. So that was a really nice feeling of asking these questions. And at the same time, I had never really thought about this because I'd never really thought, wow, this could actually integrate with hardware, which, by the way, we did at Intel. I think that in hindsight, this is one of the reasons why Intel recruited me, is we built one of the first hybrid transactional memory systems for the Intel Haswell RTM, restricted transactional memory, or TSX, transactional synchronization extensions, I think is what that stands for. And so one of my first PhD students, Irina Kalchu, Dr. Irina Kalchu, who is a phenomenal researcher and intellectual, she and I worked together at Intel, and we built this thing called InVisewell. I think we call it InVisewell. And it was a fusion of some of my prior work in transactional memory for Inval STM, and then the Haswell system, which supported restricted transactional memory, and fusing those together to make it work. Thus the name from Inval STM and Haswell, InVisewell, something like that. This is a long time ago. This is like 15 years ago, so apologies if I don't get all these details right. Anyway, so the dissertation defense, going back to that, things are going well, and I come back into the room after they deliberate, and they're all like, "Congratulations, doctor, congratulations." I'm like, "Oh, cool, thank goodness, woo. Okay, now I can, like, go to sleep, and this anxiety, and, you know, my heart rate is probably 180 beats a minute. It's, yeah. For all of you that have successfully gotten through these things, good job. It's definitely, at least for me, it was an event. So at that point, I start to realize that people seem to be pretty positive about my research, which was, again, a bit of a pivot, because we were going from this kind of like, yeah, your research really just sort of is not very good, to this whole of, wow, this could be the future of transactional memory. And then a couple weeks pass after the defense, and at this point, I think I'm working at Intel full time. I think Intel hired me before my PhD was conferred on me, knowing that I had already finished writing my dissertation. I had the pubs, and that it was just the final defense. And so I was like back and forth between Colorado and California. And while I was in Colorado, my research advisor reached out to me and mentioned, "Hey, we really like your dissertation work, and we want to nominate it for the Best Dissertation Award at Boulder." And again, this is pretty shocking to me, because just a few months ago, it felt like I was bottom rung, and now suddenly I'm, being nominated for Best Dissertation Award. This is like, holy cow. So clearly people were talking, and I guess maybe the dissertation committee had discussed amongst themselves, and so they were ready to nominate me officially. And again, this is very surprising to me, and I'm super excited, thinking, wow, okay, this is great news. Absolutely, what do I have to do? What's the process? And so I was informed that the process is basically not much for me to do, just that they need to officially nominate it, and then maybe I need to just sign something saying I agree to it being nominated. and then we'll see what happens. And then I was told too that like don't get your hopes up because there's like only one, I think it was one dissertation across all the colleges of the university that gets picked. Like I'm not sure, they probably had different segments like for the School of Engineering versus liberal arts or something. I'm not entirely sure. But basically don't get your hopes up. This is probably not going to happen, but we liked your stuff so much we're going to nominate you. And I'm thinking at this point, wow, just being nominated, this is a huge deal. And so at this point, I was informed that the deadline for the nomination was like this Friday, and it was something like 5 p.m. Okay. This small detail matters. 5 p.m. Friday this week. And so there was stuff that the committee had to do to get it prepared. And I was informed that people were going to be in meetings right up until about like the 5 p.m., but they'll get it submitted. And so I let the head of graduate stuff in computer engineering know that this is coming down from my committee and sort of be on the lookout. And he reminded me, okay, just so you know, the deadline is 5 p.m. Friday. I'm like, nope, totally understand. Yeah. And for all of you smart people that are watching this, I suspect you know where this is headed. That 5 p.m. arrives, and there is essentially no submission that's being made. And again, this is out of my hands. I just have to wait for the committee to do the submission, and I'm just kind of making sure people are aware of stuff, like the deadline. And I think at one point I was informed by the committee that, okay, they went and submitted the nomination, and we'll see how this turns out. So I reached out to the head of the computer engineering grad school and just tried to confirm that it was received. And he told me that, yes, we've received it. However, it was sent to him at about, I think what he was saying is it was sent at 5:15 p.m. On Friday, and the deadline was 5 p.m. So the deadline has been missed, and therefore the nomination won't be considered. And so I remember seeing this email, and I remember thinking, I've been working on this thing for 7 years. And I've had, like, I'm literally walking through all the challenges that I've had in grad school. Challenges getting admitted. I failed the PhD entrance exam once, and it's sudden death. So if you fail it twice, you're kicked out, right? All these struggles getting my tier 1 publications actually through the gatekeeping process. And this is over 7 years, right? Literally from 2003 or 2004 up until 2010. This has sort of been my life. Now, I worked on other things. I was still working full-time to part-time. Full-time while I was doing my master's work, and then I dropped down to maybe like 30 hours a week or something when I was in the final stages of my doctorate. And I was also still doing a little dabbling with Nautica, but the PhD was kind of the primary thing I was really concentrating on. And so, as one probably does, I was staring at this email, and I literally have the person's name kind of burned into my head. But I'm not going to mention his name, because, again, it's not his fault. He's just following the rules. And again, I'm not going to blame my committee either. They were trying to do something for me, which is great. And I suspect they probably thought that 15 minutes late, like whatever, they're not really going to be that strict. And I think that I did follow up and ask in like the kindest way that I could if there's any way to like get it into the system even though we missed the deadline by 15 minutes. And I was told that there is not a way, that basically, and did I get some attitude? Sure. That it was then told to me that I need to understand that deadlines are deadlines and that these things don't move. And it was one of those things where, again, life can be unfair, that I wasn't the one that was submitting this. There's nothing I think maybe I could do. I was just, and again, I'm not trying to avert ownership of this. Maybe I could have asked my advisors to be cognizant of the deadline. They were, though. They were just tied up in other meetings. And I think that they were of the opinion that it's, they're not going to be super strict on it, which we are involved with many of these deadlines. And even if you have paper deadlines for submission, oftentimes if you miss it by an hour, you're still good. In fact, there's times where I've missed the paper deadline and I've emailed the chair and said, hey, it's closed, but I have this done. Can you still fit it in? They'll be like, yep, it's in. So, even from things that's a really hard deadline, we've seen that people tend to be somewhat flexible. And so I think the expectation was from my committee that they would be flexible on this. So I emailed the head of the grad school back and asked if there's some flexibility, and this person said no, and be better about these deadlines. Don't just think that the world is going to bend to your will. And was that maybe a little harsh? Sure, but also, if I'm being empathetic, I can imagine from his side that maybe he's getting people missing deadlines all the time, and maybe it's kind of annoying from his perspective. Like, I can see that. Then I also emailed my advisors, and I asked them, like, if there's anything that we might be able to do, and I explained the situation, and then they said, nope, sounds like we missed it, and they were like, shucks, that's a bit of a bummer, but, oh well, we tried. Now, this was a really interesting kind of pivot for me, in that in the past, I think I might have been somewhat upset about this. I might have been like, is this really happening? I've worked so hard for this thing. I finally get to the point where my committee, who has these world-renowned experts on it, are all agreeing that this should be nominated for Best Dissertation, and it doesn't get done because of a 15-minute miss on the deadline. Like, surely we should go to the dean or something. And I thought about this. I thought about this in some detail. Because obviously, as one might imagine, I'm just sort of beginning my career. I really haven't even finished my PhD, and this would be a really nice feather in my cap to just be nominated. Even if I'm not selected, I can say it was nominated for Best Dissertation. Now I can't even say that, even though it would have been, right? And so just getting to be able to say that would be a huge win. And then it kind of dawned on me that it just doesn't matter. That as much as I would have liked to have been nominated, and for as great of an honor it is for my committee, to essentially recommend me for such a thing, ultimately, this is just a small thing. And what I should be really grateful for is that my dissertation committee, my doctoral committee, was so impressed by my work that they wanted to nominate me. This was the thing that actually mattered, that the people who were working with me, who were the experts, were so impressed by my work that they saw it as some of the best work that was going on at Boulder, at least this year. And it was really focusing in on this point that I think helped me change the narrative to realizing that getting nominated or even winning this award, this is not really what matters. What really matters is that my mentors were viewing my work in such a positive light that they were proud of me, that they were impressed by me, and that is the major thing. And all of these other things, those are all minor things. And I wanted to share this with you because when I say don't get distracted by the little things, I mean things like this. I mean things where it could appear like this is a major thing, and how can you not get distracted by this? I think that with the context that I've shared and sort of the heartbreak that I was feeling and the panic about, we missed it by 15 minutes, like, come on, like, really, nothing can be done? And the truth is, I think ultimately something could have been done, right? I think that the head of the grad school just didn't want to. And I think he just made a decision that, no, he's just not going to do it. And I don't know if I made him angry in some prior discussion or if he was having a bad day. But ultimately, he was the gatekeeper. I didn't really have any power. And it just wasn't going to get done. And at the time, it felt like something that was so big. It was like going to change the direction of my life, that it would be this huge award and it would open up all these potential opportunities, and maybe I could start collaborating with Berkeley or the other place that I hang out at now, because this is the kind of stuff that you kind of need these accolades to get. But then when you put it in the context of all this stuff, did it matter? Because this is where I teach. This is where I hang out. Did I need it? Well, clearly not. And I think that is one of the hardest lessons to learn. Because in the moment, when things are going on, it can be so easy to make these small setbacks enormous. They can become monumental. Believe me, every instinct in my body was like, how is this happening? I can't believe this. I just was livid about the possibility that I could reach this sort of ascension, and it didn't happen because of a 15-minute window. Like, oh my gosh, is this really my life? But then, in hindsight, I think what really mattered, and I think probably it may be the reason that I am teaching at this place, is that when things are not necessarily going my way, I'm not going to lose my cool. I'm not going to become an unreasonable person. I'm not going to send off a really harsh email to the head of the grad school saying, this is unacceptable, and pull my advisors in and make a huge catastrophe or some sort of massive amount of noise over this, which then may make them question to begin with why they even nominated me. Because if I can't behave professionally and reasonably, then maybe I shouldn't be nominated after all. And I didn't do those things. And the result is that I have really strong relationships with all those people on my committee. And ultimately, so I didn't get one accolade. So what? Who cares? Am I able to do the things in life that I really want to do? Yeah. And ultimately, I think that's the stuff that matters. And so I wanted to share this with all of you because I was thinking about these life virtues, and I was thinking one of the best ways to share these outside of the general is to give these true experiences where I've had to face the music and actually kind of show my mettle, so to speak, on do I really follow these philosophies, or is it just me saying things but my actions are totally different? And I remembered, oh yeah, this is a doozy. By the way, I have some other doozies that are just as bad, if not worse than this one. Maybe we'll get to that in a later episode. But for almost all of these cases, I've literally experienced something head on, and I suspect maybe all of you have as well, especially for those of you that are just further in life, just for a number of years you've been alive. Like I've been alive for 50 years, so I just have had more opportunity for doors to be thrown closed in my face. And also, I seek out failure, so I'm failing at often a much higher frequency than I think most other people are, because I really, when things like this happen, I really try not to become distracted by them, and it just motivates me more. So this is the story that I wanted to share with all of you. This is a true story, and if you happen to find my CV out there in the wild, I'm fairly certain that I know for sure it doesn't say that I won the Best Dissertation Award, because I didn't. And I think that I was discussing with my advisors, and I was asking if I could say, can I say that it was nominated? And I think they said, yeah, you can say that it was nominated, even though officially it didn't really get considered because we missed the deadline. And I can't really remember what I decided to do, but ultimately what I really decided to do was realize this is a little thing. And in the grand scheme of things, this doesn't matter. And in the moment when this was happening 15 years ago, and this PhD thing was the centerpiece of my life, and everybody that knew me knew all the hardships I was going through, and then to have this be potentially the prize, this was phenomenal. This was like wildly amazing in terms of outcomes that I never could have possibly believed would happen. And it was happening. And so, yeah, at the time it felt really big. But it also lends itself to another piece that I think is very important in terms of virtues. And it's this virtue. And this one, by the way, I think is very hard to master. I think that some argue that it's almost impossible. I think that there's a few people I know that can master this or have mastered this, and it's taken them a lifetime. But it's this idea that you only rely on internal validation, that you don't need external validation to have you understand your own self-worth. And this is something that actually happened to me when I was trying to understand the magnitude of this other thing with the Best Dissertation Award, is it dawned on me that, one, what really mattered is that the people that were in my inner circle that deeply understood my work, they saw that my work was outstanding. And then two, that I was actually greatly impressed by my own. I hate the word proud, or hate's maybe too strong of a word, but I dislike the word proud because it has these connotations to it. But I felt that I did more than just achieve what I had set myself out to do for my dissertation. That I had reached this pinnacle that was even beyond what I thought I was going to be able to reach, for a number of details that I haven't even shared on this channel, at least not yet. And that mattered more. And so having other people know that I won the best dissertation award, what does that really matter? Because that's essentially all it would be. It would just be other people could sit around and say good things or bad things about me, about my best dissertation award. And frankly, who cares? Who really cares? It doesn't matter, because that kind of external validation shouldn't really matter to me anyway. So that's the story for today. I hope that all of you liked it or got something from it. True story. And you get to see kind of me deal with life throwing me some curveballs and how I actually behaved in that setting. And to the best of my knowledge, this is how I behaved. And I want to share, too, that this was not easy. When I was dealing with this, it took a lot of control for me to not send an email to the head of the grad school and be like, are you effing kidding me? Like, every bone in my body wanted to send this and pull in the dean and be like, is this a joke? Like, really? This is like... But I thought deeply about it, and I thought about, like, does this really matter? And what are the side effects? What are the potential bad things that could happen if I behave poorly, or if I really try to sort of flex on this situation rather than just sort of accept that, well, he's not wrong. We did miss the deadline by 15 minutes, so if that's how they're going to be, that's how they're going to be. And ultimately, that's basically the conclusion I came to. And to this day, while I definitely think that I'm not a perfect human being in a bazillion different ways, this is one of those things that I look back on and I think, yeah, I think I handled that in a way that I feel good about myself. I feel like it would have been really easy to take kind of the low road, especially given all the obstacles and challenges that I had experienced. And I didn't do that. I took the high road. And I look back on it now and I think I'm more happy about how I dealt with that than if I would have dealt with this in another way and even won the award. Because at that point, it's like, at what cost? And the truth is, I think that other people are watching. And whether we care about their validation or not, I think that behaving in a good way, whether people are watching or not, I think ultimately matters, because we know that we're behaving in a good way. We can look at ourselves in the mirror and say, you know what? That situation wasn't super great, but I think I did pretty good with the curveballs that I was thrown. And ultimately, I think if you can convince yourself of that, with an open heart, with a fair mind, that you really can say, yeah, it was hard, I wasn't perfect, but I think I did pretty well, and you're being honest with yourself, I think that is the road to really reach this level of enlightenment, where you can keep your cool when the world's falling apart around you and everyone else is going into full panic mode, and you just are calm. And you're the stoic in the room. You're the one that isn't losing your cool, that keeps your head on, and becomes the force that actually is leading people to the right decisions, getting people to think and behave rationally when the rest of the voices are succumbing to emotional overload, which again is something I think could have very easily happened here, is let my emotions control me. I had lots of emotions in that moment, and I think that's one of the reasons why we don't let our emotions control us. It's okay to have emotions, but don't let them control you, because oftentimes those reactive emotions will lead us down paths that are not necessarily the right path. They're going to be something that we're going to think about later on and have serious regrets that we gave in to those emotions. So yeah, now I'm going to pause real quick, refill my soda situation, and then we're going to continue on equality and inequality. So, talk in the words of Flossie Carter, I think that's his name. Yeah, something like that. Talk amongst yourselves. Okay, we are back. Yep, and we're recording. Cool. So now let's talk about equality instead of inequality. Now there's existing data, and maybe in a subsequent episode I'll try to find data that substantiates this, but I suspect if you do a search on the internet, you'll find that this has been substantiated by a ton of studies, is that people tend to find reasoning about equality easier than inequality, especially when they see it in sort of code form or mathematical form. And to demonstrate this, we have this example in Mentor on this piece of code. This is from ClickHouse. And we have a whole bunch of checks for inequality. And so I want to give all of you a moment to look at this code and try to process this real quick before I continue. So we'll give you a few seconds to look at this and see what you think is going on. Okay. I'm going to explain it now. And if you'd like more time, feel free to hit the pause button. But let's dive in. So, for those of you that spend time trying to understand this code, what you probably have figured out is this is going to search through this string pointer, something of that nature, and look for one of these characters. And if it finds one of these characters, then it's going to exit out of this and then do stuff. And if it does not find one of these characters, it's going to continue to move forward. And what it's looking for with these characters, again, this is for people that have stared at ASCII and understand like these escape characters, which each of them have, because this is the escape sequence, is it's looking for this slash, a return line, a new line feed, a tab. I'm not sure what the F is. Feels like a 4 something. A B, I think that's bell. This is the null character, and this is, I think, just an open quote, I I think. That's how you get an open quote when it's surrounded by open quotes. Or single quote. Oh, and by the way, too, it has this check right here for the double quote. So, yeah, I think that's what's going on. And this is pretty common when you're essentially looking for like these delimiters. Essentially what you're looking for, in this case, it's not exactly this, but the higher order bit is things that are special characters. So the alphanumeric stuff is acceptable. It's going to all ignore that. But then the special ones, it's not all of them, because like there's other special characters that might be considered in this space. Like, for example, the space character. Like, where is that one? Because if you have tab, like, do they have the space character? I don't see it in here. And I feel like there's some others, too, that I'm probably missing. I'm just looking at my keyboard here to see. Yeah, and then there's also just the special keys of, like, the exclamation point, at, pound, $, all that stuff. Those are oftentimes considered special characters. This is a special subset of that. That's usually related to things that are indicative of white space. That's usually what, but again, it's not exactly, because these quotes are not exactly white space. So there's something that's going on here that they're looking for. But what makes this a little bit tricky at first, at least in my mind, is it's all inequality. So they're doing this, and it's not equal to this, not equal to, and so it's like, okay, you have to kind of keep this list of all these things that it's not equal to. Which, if it was just equal to, I think we would reason about it in a much easier way. Like how it is this here, is that if it's equal to this or this, and again, you have these here. So what's interesting is mentor comes back, and by the way, I was trying to find this as an example before looking at mentor. So I didn't know what mentor would say, but it seems in this case, mentor kind of agrees with me. And keep in mind, mentor is its own thing. So mentor's going to do what mentor's going to do. It doesn't listen to Goju, even if I might be one of the people that designed it. But it's its own AI thing. So what's nice, though, is in this example, it reinforces the point that I'm trying to make, which is looking at equality tends to be easier for us to reason about than inequality. So it changes it. So instead of it being all these invalid characters, it changes the narrative to where it's a valid character, right? So it inverts it so it's a positive. It's not saying that it's invalid. It's saying that it is valid. And then the checks themselves are all on equality. So it basically makes a list of all the things. By the way, I like this much more than this, because this can be expanded on, as we saw in one of the prior episodes, very easily. You just add another element, and then this code here that iterates through it, this doesn't change. This elides away potential fat fingering of logic. Strongly recommend. Is it potentially a little bit slower? Maybe. You create this as like a static variable inside of this. It's going to be initialized once. It stays in memory, and might actually be faster, because now it's guaranteed to have certain stack properties, contiguous memory properties, that you might not get if it's done this way. That's another rabbit hole we can get down onto, but for now, let's just focus on the fact that it's an equality check here. And then, if it is not equal to this, then it returns false. So for any one of these, if they're not equal, then it just exits and says it's false. which is essentially what this was doing before, is any one of these is false and it is going to exit out. And that's basically what it's doing here, is it's saying that you have to be equal to this. And if you aren't, I'm going to exit. And because this is all ands, not ors, it knows that I just need one. I just need one case where it's not equal to, and I can exit. So then it knows too that if you pass all of these checks, so none of these have been false, it has to be true. Then when you actually call the code, you have something as simple as this, where it says, while this position is less than this pointer end, and it's a valid character. And I think that is much easier than this. Not only do I think this is much easier than this to reason about, because now I know, oh, it's just looking to make sure, is this a valid character? And it's going to do that over and over again, which is awesome, because now I understand the higher order bit of what's processing here. I can even write another function that abstracts this. On top of that, the actual function itself is very easy to reason about, because it segments out the actual items that are going to be iterated on. And then it says, look, we'll just iterate over a range. Like, we love ranges, right? There's not even a check here. Like, I love this range syntax. This is a thing of beauty. Just this thing for this, and you can't really get the first order logic wrong. Because there is no first order logic, which is how a lot of these for loops really are. Not all of them, but a lot of them are. And then the actual first order logic that you have is just this equality. It's one equality. Oh, this is heavenly. And while this may not seem like a big thing, right? This is one of those cases where, okay, why are we spending 30 minutes or whatever talking about something that is so basic that we all know this? Sure, that may very well be the case that we all know this. The key thing in my mind is that software tends toward entropy. If you're writing software and your software is being used, then your software is going to expand because people will want bug fixes, they will want new features. There's no piece of software that I've ever seen, strong claim, but this is my own personal experience, that is successful and people say, wow, this is a great piece of software, you're done. There'll be no more updates. You're finished. It's the opposite. It's the software that nobody is using, that nobody cares about, that is done. Because nobody cares if it gets bug fixes or updated. Therefore, software that's being used will naturally be updated, and more updates to that software means more entropy. And the more entropy you get in the system, if you don't manage that entropy, you will move toward a space of so much technical debt that the code essentially can no longer be maintained. And if you don't believe me, look at React Native on Mentor and look at some of those control expressions that we talked about and ask yourself if you can rewrite that code. Because I can't. And I've been doing this for like 30 years. And if I can't do it and you can't do it, who is going to do it? And if that's the entirety maybe of your entire source code, then this is why a lot of people want to write code from scratch rather than using existing things, is it's oftentimes easier. So if you want to build, I think, large real-world software systems, you have to be able to manage technical debt. And you have to understand that making things as simple as possible, going back to this notion of mastering the basics, is one of the best ways to manage entropy. And it's the small stuff. It's the small stuff like this that I think adds up. That this eventually scales and turns into something much worse, which is, I'm going to find it because I'm pretty sure it's in ClickHouse. And you'll see an example of what it looks like when it's not being maintained. And maybe we'll talk about this in this episode, or maybe the next episode. I think we looked at this before. Can I? Mentors. There we go. Come on, buddy. Enter's overloaded because it's thinking, and okay, so it solves stuff. But as you can see over here, now I can probably make this bigger. Okay, yeah, as you can see over here, whew, these are some big control expressions. The higher order bit, I guess, from these is that each one of these is adding exactly one new variable to the end. This is the pattern that I think I observed, is that this one ends at sync file system cache, and then this one adds one more to that and adds drop cache. This one adds one more to that and adds drop skip index cache, and essentially continues along this approach by adding these single variables with each control expression. And that's what it does the whole way through all of this. All of this. That's all it's doing every time, just adding one more. That's at least my pattern recognition mind from a quick glance. But if you follow this, I think that that's what it's doing. And this is an example of, I think, really bad technical debt. And again, for someone that hasn't programmed very long, they may not understand like what's going on here. Why do you do this? And the truth is, there's really no good reason to do this. I understand they want to have the sequence of else ifs, so they can do this thing, and they may think in their head that just adding the additional variable is the way to do it. You could write a function, right? You could write a function that is having a summation thing, and there's one more thing being added. And so, like, just a simple example of this. Okay, I wasn't planning on us coding, but, you know, sometimes we just gotta code. So let's just code here, and let's just find a simple way to demonstrate this in terms of how we can do this maybe better. Okay, void, we'll call this summation, and this is going to do all of this stuff. I'm trying to think if I should just, yeah, I'll just take some of these guys directly just to show you how it can be done. And I'll use the actual things that they have. This is not exactly going to compile because they're going to have a bunch of stuff in here that we're going to remove. So we're going to get rid of all of these things. By the way, this is just me doing this, mostly following their mechanism, and I would probably do this like maybe in a different way, but let's just take their approach. Okay. This is right. Yeah. Why is this? Reload. Why does it not like that? Oh, there we go. Just slow on the IntelliSense thing. Okay. So it's going to be really a comparison against this guy. So it's going to check to see if this exists. Okay, so we'll break this down a little bit more. This seems to be a Boolean. This is the Boolean of like, do we want to do this thing? And then this n-opt is going to check to see if this is less than this thing. And if it is, then it'll do the thing that's in the control expression, I guess. Yeah. And so what we will do is we will then create this thing that's this sum. And there's a number of different ways that we can do this, but we'll just do this. Okay, it's a terrible name, but we're just trying to write this quickly. Okay, now this is going to be this. So we're going to update this sum. So the sum is going to get updated with this thing. By the way, this plus 1, do we add this plus 1 every time? I think we do. Plus 1. No, we do this. Sorry. Less than. Weird. Yeah, the reason why I'm saying this is weird is, again, mastering the basics, is they're doing this plus 1 every time, and they're trying to make sure that this is less than. So they're having this, like, here's what the math is looking like in my head, is I'm saying 5 is less than 5, which is false, plus 1, true. But true. So, like, and I get that it's two comparisons, but I also understand that arithmetic is arithmetic, and so that's an addition. So I'm confused here in that it's like, it feels like you're trying to save the comparison on equality, but you're adding an addition operation, which in some sense I think is, I mean, that's a mutating operation. That's more work than usually just a check on a comparison. And so I don't know, maybe there's something I'm missing here. That's entirely possible, but I don't know. So anyway, so this is why I was pausing, is, look, you can do this as this, like this, we'll call this option number 1. This is what they did. I'm going to go with option number 2, just because, and by the way, this is the beauty about mastering the basics. I didn't come into this even thinking about the plus 1. I'm more trying to fix this other problem, but then I'm seeing the plus 1 and I'm trying to understand the ramifications. The reason why I was thinking about the plus 1 is that if we're doing this every time, then we're doing the plus 1 every time. But it seems to me like they're actually doing the plus 1 just once. That's why they keep adding it onto this. So they want these other things plus 1. What they really want is that less than or equal to check. That's what I think is going on. And so I don't know that I would do it like that. Okay, so now we have this coded the first way, or the first thing. And by the way, let's just say, I don't know, true, and then this is our next one. We'll say false. I don't know, we're just going to just make stuff up. And what's the next one that we have? We have oh, these are, oh, these are actually ints, that they're overloading it. Okay, so they're using, these are ints, my bad, and they are overloading the int value to where if it's 0, then it means false, you're not doing it, and if it's non-zero, then it's some value, and they're using the value. Sorry, it took me a second to figure that out, because they're checking this here for 0 or non-zero, and then if this is true, basically any non-zero, then they're using the sum here, which results in this thing. Cool, okay. I'm a little slow, but so now we have this thing. So you have the same thing with reload dictionaries. We have this, and then we have this. So we're going to do the same thing. We're going to have this be our new guy. By the way, we'll just set this to 15 now, and this will be equal to 27. These are just random numbers that I'm putting in here. And then we're going to continue to follow the logic. Update sum and return. And we'll do sum. And now we're just doing this. Okay. And the reason why we don't have to add the reload embedded dictionaries is it's already added to sum. So all we need to do is just have it be reload dictionaries, because it already knows the other thing. Cool. Now we go to this next one. So this one is going to be reload models, and we'll add this, and we'll set this to 41. I know a lot of you wanted it to be 42. I wanted it to be 42 too, but at the last minute I changed my mind. Update sum and return. We're going to add this. Oh, and we need to continue to change this. By the way, I'm tempted to use my find and replace, but I won't. I'm going to just type a little bit more. Okay, so we have that one, and then this next one is reload functions. Then with the next one after that is reload function. Next one after that is reload asynchronous metrics. And I think that's all we have for now. And we'll set these to, let's set this one to 0 just for kicks and giggles. Do we want to do that? Let me think here. Okay. As I'm dissecting this and trying to rewrite this, I realize something. And by the way, I'm going to leave this all in because I think that I made a mistake in terms of the actual logic, and it makes it even more interesting now to me on why they're doing this. And I don't know that I figured out the solution. We may need a little time to think about this together. But what I think I realize now is the way that this is structured with the ifs is it will walk through a list, and it will be the first one they run into that is non-zero is the one that will do the full calculation. And that's the only one. Yeah. Because so what will happen here, just roll with me, is that these are going to be, let's say that this one is 0. So it'll be 0, and it'll say, yeah, so 0 and anything is false. And I'll continue to do that. Let's say it gets to this one here, and this one is non-zero. It's going to say, okay, this one, you're non-zero. You're the value 7. And then it's going to say, okay, cool. This, then we need to, oh, wow, this is even wackier. Yeah, okay. No, I think I got it. Yeah, I get it. I get it. So there are cases where it'll do this update, and they are storing it as these individual things that are over in this separate calculation, because it can be calculated in some cases and then still be false, and then it wants to go on to the next one and then recalculate it. So basically, you can have a case where this thing could be true. This could be true here. This is 17, but this thing is false. Let's just make this is false. False. Or this is 17 and this thing is 38. Okay. So 17 is true, and then this is false, and it's going to be false. So then it's going to go down here, and then it's going to do this calculation. Okay. So now I think I understand the higher order bit, and we can still do the method that I was proposing. It's just slightly different. It still follows essentially the same logic, but we're going to do it now as a for loop. And so we'd have I equals 0, I is less than whatever the total number of things here. Let's just call it K max array, and we'll do this. Okay. Now, oh, that was strange. Did I miss something? Oh, right, because it doesn't know what this is. Okay. In const K max array, this is going to be pseudocode-ish, because I don't want to write all the code that would fill this out, but hopefully you'll get the idea. And it'll still follow the premise that we had before. So what we're going to do is we're going to create essentially the same thing that we did before with these enums, right? We're going to have an enum that's essentially the list of all these things. So that's what they would have in their list of all these reload things. It would be this reload array. So it'd be something like this. A std vector of ints, and we'll call it the reload. We'll call it v reload, and then we'll do something like v reload is reserved on k max array, so it's going to be the size of this, and then there's going to be essentially a populate the v reload guy. I'm going to populate this with all of the values that you would get in these reloads. And again, because of the way the ifs are structured, if it hits any one of these that's true and it executes it, it only does the one, and then it exits. That's the case of this. So we're going to do the same thing, except we're going to access these as arrays. And so this will be like the... how would you... I think, yeah, you do it like this. So it'd be v reload on I. Yeah, because you want to make sure that this is true. And then you would say, and n opt is less than or equal to sum. And if it is, then you're going to do this stuff in here. Whatever this is, do whatever, and then you're going to break, because you're going to be done. You're going to do one time. Then, in this thing, you're still going to do the sum thing that we were mentioning. You'll do the update sum. It doesn't matter if it returns it now, because you're going to use sum here. And you need to do this update sum each time, because you need it to trigger even in the event that this does not trigger. Okay? And the notion basically is that this has to be a non-zero value. So even negative numbers will trigger this. And so let's just assume that their addition is actually what you want. We're gonna follow the semantics. And so in this case, in fact, we don't even need the update sum because we have it in a vector now. We can just do it like this. Is this into v reload sub I? There we go. So now we've updated the sum. We've incremented our sum by whatever this thing needs to be. And so the sum will be updated. Then we check to see if the v reload is some non-zero value. If it is, then we check to see if this is less than or equal to the sum. If it is, then we'll do whatever it is we're going to do, and then we'll break. Now this will essentially do all the logic of the updating on the sum check before it checks the conditional, which is what you need for this behavior. And then once that sum is updated, it'll check if this is a non-zero value. If it is a non-zero value, then it will check to see if this thing is less than or equal to the sum. If that is, it will do whatever the thing is that it's going to do. And in this case, what we saw is it's going to have some set operation. By the way, this should be basically a vector of function pointers. You can just do this as a vector of function pointers that then get invoked and then set. It looks like it may require some additional work to figure out the parameters that you need to send to this, which is not too hard to do. But it does look like in some cases you have these, I mean, there's specific work you could do. You could, if you wanted to get rid of all of these control expressions, you could do the method that I'm proposing. And then you could, if you really wanted to, you could embed a switch. Let's say you don't want to do the work of figuring out all the function pointers properly. You just do a switch inside of that if that then is checking on these guys, and then it invokes the right function call. This is sort of, I would do it in like a slightly better way, but just so you can see concretely what I'm describing is then you'd have a switch on is that going to work? Yeah. You'd have a switch on I, and then it would be things like in this case over here, this is start merges, right? And so, whoops. Start merges is our, start merges is our guy. So we go over here, and then this would be K start merges. This is our case, and then we would break. And then in this particular case, you would start merges. You'd basically just take this line of code. Now this, I don't totally love this, just to be honest. I think you can do better than this. But just to demonstrate the point of how you could handle it if you didn't want to do this fully the right way, this still gets rid of the massive if control expression explosion, and then is allowing you to handle the overloaded function calls that are more complex than just the set whatever operation. These set ones can be fixed by a function pointer, essentially. That's in this vector, so it would be like a vector of function pointers that are being set. But then in the cases where you have more complicated behavior than just setting some Boolean, like in this case, it has multiple parameters that you'd have to figure out, and so this would require some additional work. You could hack this by embedding a switch that does the more complicated stuff. There is another way. You basically have some sort of struct that knows the right behavior for these individual calls, and then you pass that struct to this thing, and then it then pulls out the right information from this based on the function call. That's one of many different ways. But minimally, what the change we made would do is you get rid of all of this. All of this red stuff is just gone. And on top of that, you make it clear what these things are. And then as new things get added, and I can tell you based on what I've seen, these are essentially lists of behaviors. So they're actions that you're going to take with essentially this database. You're going to reload the embedded dictionaries, or reload the dictionaries, or reload the models, blah, blah. Load the packages, drop the file system cache, right? So these are all just behaviors for this database, which basically means, one, you could delete behaviors. That's a change for the modularity of the software. On top of that, you could add new behaviors. So if you think for a moment that this is fixed, that if you think that like, oh, well, they got to here and they're done, there will be no more, I can pretty much guarantee you that that's wrong. And the reason why I can tell you this is that if ClickHouse continues to get used, there's a behavior they don't have that they're going to add another to this list, and it will be the 51st behavior, and then there'll be a 52nd and a 53rd, and so on and so forth. Like I've been down this path many times, and this happens in perpetuity. That this is a real kludgy way. No disrespect to ClickHouse, I get it. When you start doing this, at first it's easy. Just do this, but then at some point you get to this, and it's like, this is just a kludge now. What are we doing, right? And again, this is a really good repo. It's strange to me that, I mean, by the time you get to this point, I think most of us that are real software developers kind of know. I mean, I suspect even the ClickHouse people know that, like, this is really not good. This is so easy to accidentally break. Like, all you need to do is just accidentally delete one of these values, right? Or you put the same value twice. There's no check on this. So you accidentally have flush logs twice, and now the whole count is broken. And you know how hard it is to figure that out in this list? Pretty hard. This is technical debt waiting to break the system. Pretty, like, again, no disrespect to ClickHouse, great repo, but this is some pretty amateur stuff here. And you should get in front of this, because this is more likely than not going to break your system. Relying on the fact that people are going to get the copy-paste mechanics right is a really bad strategy. On top of that, the way that it's based, as I can see right here, is there's an ordering to the actions, that it's following some predetermined list. That's why it's adding these each time. What happens if you have an action that shows up here? Now think about that for a second. Each of these adds one more variable in this predetermined list in that specific order. And so, like, when you add drop file system cache has to be included, right, in these other ones. In fact, yeah, they just did it. They literally just did it, where they reordered it in the wrong way. This is what I'm talking about, is right. So what you're supposed to be doing in this structure, like, we literally just stumbled on an example of, like, quick way to break this. You're supposed to be adding this item to the end. And so this item to the end, and then this item to the end. Where is it? No, they decided, no, I'm going to add it here. You're breaking the model, because now the next person is like, wait, I thought you added it to the end. And they're looking at this one saying, well, it's not the end. And so, but these guys recover and then add it here. But notice that nobody's fixing the sync file cache. And it's supposed to be before the drop file cache. So if you reorder stuff, like, for example, right here, you insert one right here. What you might do is you might remove the last one, which is drop file system cache, but you keep this one, and you add an if-else between these two, and now you've done the wrong thing, because you were supposed to remove sync file cache, but you didn't. You just followed a mechanical process of deleting the last one. This person got that wrong, and now you've added the wrong number. It could happen. Easy way to break this. And the person making the code changes, like, as the code reviewer is looking at it, they'll be like, oh, cool, yeah, you deleted the last one. Yep, you did the right thing. You insert it, you're good. And then they're going to say, oh, and by the way, you need to maintain all these other ones. So the new thing you added, we'll call it unsync file cache. You have to add unsync file cache to each one of these. Every single one has to have this now. Sorry, you just have to add it to the list, because that's the way the system works. Don't miss one. You miss even one of them, it's not going to work. That's crazy. That is a very clear sign of bad design. This should not be in, like, and again, I'm not trying to beat up ClickHouse. I'm just trying to make the point that, like, there's almost no argument that I can think of that this is good code, because it's not. This doesn't mean that ClickHouse is bad. ClickHouse could be fantastic, but just because you have coders that are generally pretty good and generally make really good decisions, it doesn't mean they always get it right. And so this should really be fixed, because these are bugs waiting to happen, and they probably have already resulted in bugs. If we ask the ClickHouse folks, I bet that they can, if they're being honest, they probably would tell us stories like, oh yeah, Fred was working on this and he got one of them wrong and we had to debug it. It took like 2 days. And so, yeah, don't do that. Just do it the right way. The right way is this way. Have this vector of these items. Create the array that captures all of the items. This is the only thing you maintain. And then do the summation that adds them each time. You don't even have to do this piece. You just have this now be. Oh yeah, we don't even call this anymore. We don't even do this. Then you just have sum, and you add it to this. This happens each time. You check to see if the v reload is a thing you want to mess with, and that it satisfies this condition. Then you can go into the switch. I'm not thrilled with the switch. I would do it better. But again, this could be a very lazy way to make this better. I'd probably make this an embedded function, because this switch is going to be pretty big for all the cases we have to add. And then minimally, you can add any number of enum elements that you want, and it will just work. Like literally, that code is just going to maintain itself. The only thing you'd have to add is the set behavior, which is a new element inside of the switch. There's a way to do dispatch here that you could have essentially a vector of dispatch functions, which is how I've done it in other cases. And then the dispatcher just invokes the right function with the right parameters, and then you essentially get the right behavior. So anyway, the higher order bit of all of this is a great example of just mastering the basics. It's just making sure that we really master the basics, and then when we do, we see that this is not good, and then we understand how to do this in a better way, like a better software design way, and then we do it that way. And then this whole code becomes better. And this code footprint is going to shrink dramatically. I mean, look at this thing. Like this should send shivers down everybody's back. Is like, if you ever have a function that needs whatever this is, right? Like this is a lot. This is a lot to take in. Imagine that you have a bug in this function, and they're like, yeah, just look at generate next system statement. It's a piece of cake. It's just one control expression that's going wrong. And then you start looking at this and you're like, oh my gosh. Wow. So if you see something that's starting to look like this, it's probably a good indication that, yeah, like if you have almost 100 lines of variable initialization, and keep in mind this would be well over 100 lines if they didn't do all the pluses here. Although in fairness, this is just doing an addition. But man, and again, like what does the 3 mean? What does the 8 mean? Yeah, literals in code. Yeah. Anyway, again, ClickHouse, great repo. Truthfully, let's go back and see ClickHouse. It's good. It's pretty good. But just because you have good code doesn't mean that you won't sometimes go off the rails doing some stuff that maybe it was okay back when you first started coding it, and then it just never got properly rewritten in a way that made it have less technical debt, and then it becomes this monstrosity. And so we can fix these things. But I think that we can really only fix these things if we have a strong mastery of the basics. So when we look at stuff like this, we can say, this maybe not be the best way to do this. And I've seen on Goju Tech Talk or other places like a better way to do this. I'm going to try to do it that way. And also, just to be clear, when we first started approaching this, I got this wrong, right? Because I thought it was easier than it was. And as we start doing the less effort way, I realized, oh yeah, that's actually not going to work. And that will happen, right? Like, again, as I started this podcast, I was saying that oftentimes I will see something that like we kind of need to fix or we need to work on, but I don't know exactly how we're going to fix it. But we're going to go in this direction. And then as you start to dig into it, it becomes more and more clear, like what it is you're actually doing, which is what happened as we start to dig into this, is we'll start prototyping it and being like, well, how would you fix this? And we'll kind of dabble, and then we'll realize, oh, that's not going to work. And we do some pivots, and then finally we get the structure, and we're like, okay, this is how you would do it. And then we go back to the original code, we modify that, and then we end up in a good spot. So, yes, this is our mastering the basics, never stop growing, and then lastly, not getting distracted by the little things. Okay, one last thing I want to share, and then we're going to wrap up this super long podcast. Oh, and this all originated from preferring equality over inequality, and I think that... Did we still get that? No. That was the other problem, and Mentor did get that. But then we went down this rabbit hole of also looking at technical debt. I'm actually not entirely sure how we got onto that second part, but that's more, again, mastering the basics. Because again, this is all basic stuff. There's nothing mind-bogglingly complex that was going on in those control expressions. So even a relatively junior programmer that has a mastery of the basics would be able to look at that, I think, and say, this looks a bit suspicious. Maybe we can do better. And then the last piece is super display. So as I was mentioning before, I'm really keen on growing, and I follow the Archimedean spiral myself. You know, it's this kind of thing. You start in the middle and you get bigger and bigger as you're learning more. Is also what I teach at the university, and I've been doing that. And one of the things that I did is I found this new app called Super Display, and as we were messing with this before, we were seeing cases. I'm just going to move this off to the side. Move this here. We were seeing cases where Goju couldn't do real-time updates. But we can now. Yeah, there we go. So we've got our tablet guy that we can do the drawing for this stuff, and that's going to be super useful as we start to draw things like the structures of machine programming systems, and how we may start with some sort of code that we may transform into certain formats, and then we are going to ingest them maybe in some sort of ML system, maybe a neural net, maybe we'll train, do whatever, and then eventually we'll then pass the results through some inference that will give us something. And so being able to draw is going to be super critical for us to dive into some of these harder problems where to code it would be 10,000 lines. And so I might not have the time to do the whole code. And so instead, we can sketch out the higher order design on how we would approach this. And then all of you can decide if you want to build it, or maybe it's built partially and you can plug and play. And then the pieces that don't exist, you can code up. So, but the moral of the story here is there we go. Focus on the important stuff. Never stop growing. So this is actually important, at least to me, to be able to do these visuals, because without this, my hands are a little bit tied in what we can show. That's going to require that I master basics on things that I don't know yet for this podcast stuff, particularly how to do the tablet stuff where it's going to cast to the stream being recorded. I think we've kind of got this figured out now. And again, the solution to this is this guy here, the super display. Super display is what got us there. Pretty excited. So this is, if you're not aware of it and you need to do something similar, super display is our guy. And so now we have, I think, most of these things all going. So on our checklist of these pieces we need, I feel like we're making for our progress. We're learning. We're doing all this stuff together, and that we don't sweat the small stuff. So who cares about the stupid, dissertation award nonsense? But it does matter if we can or cannot do drawing, because that's an entire space that's closed off. And at least for me, that's unacceptable. And so I'm not going to care about the dissertation award thing. I'm going to feel the emotion and then just get over it. But I'm not going to give up on the visual piece. And the way that it was before, like having OneNote update itself every 3 minutes and that painful process, no, that's not going to cut it. But doing something like this, this works fantastically. In fact, it's so good that we can literally do it's just so fast. Now, of course, you're going to have to deal with my terrible handwriting, which my handwriting is pretty terrible. And my students often, there's going to be a new skill that all of us are going to develop, is reading Goju's handwriting, or trying to. So I apologize in advance. I'll try to get better, but I'm 50 and this is what it is. So we'll see what happens. I think that's it for today. I'm super excited that we got to cover all this stuff. I hope the stories were engaging for you, and the code stuff. I particularly hope that the code discussion resonated, especially getting us to fight some of the technical debt. I think that with the AI coding assistants, we are writing more code than we've ever written. Unfortunately, I think some of the fidelity of that code is not super great, but maybe together we can work on getting this code improved. and we can keep, yeah, keep the quality high, keep the software amazing, and keep growing. Thanks, everybody.